Okay, so now we go to the calculation part for the topic 3C. So this one will be the conversion of mass, volume, particle interchange between these three units. So the idea is very simple here. Whenever we want to change volume to mass or mass to volume, so we always convert to moles. Okay, example, they give you 12 dm cube, you convert to moles. Then after that, use the mole to convert to gram. So if they give you gram, you use the number of mole equals to mass over mass to convert to moles. Then use the mole convert to dm cube. Okay, so these are roughly the ideas now. So we try the questions here. What is meant by relative molecular mass? So it's the average mass of one molecule compared to 1/12 of carbon-12 atom. So calculate relative molecular mass for the following: zinc oxide. So we check here, zinc is 65, then oxygen is 16. So it's 65 plus 16 equals to 81. Relative mass don't have any unit because it's how many times heavier. So you don't have any unit here. Copper 2 chloride is CuCl2. Okay, because Cu is 2 plus, Cl is minus, so the formula is CuCl2. So Cu is 64, chloride is 35.5. Okay, will be 135. Hydrated, so Cu SO4.5H2O. So it will be CuSO4, then 5 water, you get 250. Then what is the mass of 0.5 mole of copper 2 chloride? So in complete table 3, so we have to look at the molar mass. Will be 35.5. Then calcium is 40, the molar mass is the same. Then it's also 6.02 times 10 power 23. So this is also 6.02 times 10 power 23, because 1 mole of substance space 6.02 times 10 power 23. Then what is the mass of 0.5 mole? So what do you use? We use the number of mole because mass over mass. I have half mole. Then calcium, copper 2 chloride is 135. So I add in the molar mass is 135. Then I will get my mass is 67.5. Number of atom found in 20 grams. So first convert your gram to number of moles. So 20 divided by calcium is 40. I get half mole. Then from there, you convert to atom. So half mole, I have half mole, then the 6.02 times 10.3, then I will get the atom will be 3.01 times 10.23. Calculate the mass in gram for this number of molecule. So first thing, convert the number to moles. You get 2.5 mole. Then from there, convert the mass. So 2.5 mole, we bring it over here. So oxygen gas is O2. So 2 times 16. Then you get a good mass equals to 80. Then you go for this one. Okay, for this one, you have to calculate how many C you have. So 1, 2, 3, 4, 5, 6. Then we check the hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then oxygen, 1, 2, 3, 4, 5, 6. So this technically this is your glucose. So the empirical formula is simplest ratio 6, 12, 6. The simplest ratio will be 1 to 1. So what state the relative molecular mass? So you have to calculate the mass. 6 times 12, then 12 times 1, 6 times 16, you get 180. Then by looking at this diagram, you know it's 60 cm cube. So now you have to find the mass. So first thing, change your 60 cm cube to molars. So 60 cm cube is equal to 0.06 dm cube. Then so use the volume molar volume convert to 0.025 mole. Then from there, you find the mass. So 0.025 mole, bring it over here. Then the mass of helium is 4. Then you're able to get the mass equal to 0.01. During the spot day opening ceremony, balloon filled with the helium gas. The balloon deflected after a few days. Explain this. So very simple. It's all tiny and discrete particle. Then the particle move freely. So you actually go through the empty space between the balloon wall, then from high concentrated area to low concentrated. So this is about diffusion. So the helium particle actually diffuse out from the balloon. And it's the same thing. You do the calculation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see, 10. 1, 2, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17. And then 1 oxygen. Okay. 16. Let me check again one more time. Check the hydrogen first. 3, 3, 6, 7, 8, 9, 10, 11, 12, 13, 16 here. So after that, 10 times 12 plus 16 plus 1 oxygen is 16 also. So you get this one. So remember, molar mass, it has unit gram per mole. So this is something that you need to take care about. If related molecular mass, you don't have unit. But molar mass have, because molar mass stands for the mass for 1 mole substance, means how many gram per mole. Okay, then I got 0.02 mole. How to find the mass? So mass over molar mass. So the mole is substitute 0.02 mole times 152, you get 3.04. Then how many molecule? So first convert this to mass mole first. 7.6 divided by 152 equals to 0.05. Then find the particle. 0.05 times 6. This one, they're using the Na, not using 6.02, it's using 6 times 10 power to the 3. So you need to be careful with it. They just sometimes they will use 6.02, sometimes they use 6. So you have to refer to the question. But most situation, you use 6.02 because the syllabus is 6.02. Okay. Then after that, determine the mass. So use the mass over molar mass. So this one you divide 6 because the Avogadro constant is not using 6.02. So you divide by 6. Then you get this mole. Convert the mass, you to use mass over molar mass. So 0.125 times 152, you get 19 gram. Okay, so refer to this one. Same thing, you have to calculate how many C, how many H, how many O. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we check the H. 1, 2, 3, 4, 5, 6, 7, 8. And oxygen we have 1, 2, 3, 4. So the empirical formula cannot simplify this, so it will remain the same. The molecular mass, you have to calculate that 9 times 12 plus 8 times 1 plus 4 times 16, you'll get 118. Then for this side, caffeine, 1, 2, 3, 4, 5, 6, 7, 8. So C8. Then hydrogen, we have 3, 6, 7, 10. Then we have oxygen 1, 2. Nitrogen, we have 1, 2, 3, 4. So this is the mass. Then simplify, divide by 2. Then the molecular mass, you have to follow the original. So 8 times 12 plus 10 times 1 plus 2 times 16. Empirical formula is simplified version, so you have to simplify it. But it's not an actual mass, it's just a ratio. Then we get 194. So calculate number of molecule in 3.6 grams of the aspirin. So first, use the mass over mass to convert to mole first. So you get 0.02 mole. Then from there, find your molecular. number of particles 0.02 mole, you put it here, then times 6.02, you get the number of molecule equals to 1.204 times 10 power 32. So a caffeine, a cup of coffee contains 0.005 of mole of caffeine. Calculate the mass of caffeine. So use the mass up. So the mole is 0.05, then the mass is 194, you get the gram equals to 0.97. Same thing, this one, you have to calculate out the how many C, how many H. So 1, 2, 3, 4, 5, 6, 7, 8. So C14. H 2, 4, 6, 7, 8, 8, 10. So 18. And O is 1, 2, 3, 4, 5. Then N will be 1, 2. Okay, so this is the molecular formula. Then calculate the molar mass. So take in the carbon 12, hydrogen 1, oxygen 16, and then nitrogen is 14. You calculate the mass will equals to 294. Remember, molar mass has unit. Then after that, calculate molecule in 3.8 grams. So you divide first to find the number of mole equals to 0.01293. Then use that to convert the number of particle. Put in the 0.1293 here. Then you get the particle is this much. If it asks for atom, then you do times 39, because in here we have total 39 of atom, so you times 39. So mass of 0.05 mole, so you put in the 0.005 mole, 294, you get 1.47. Empirical formula definition. Empirical formula for this, can we simplify? Yep, cannot, because the 5 cannot be simplified anymore. So you remain the same, means the molecular and the empirical formula are the same formula.